In this video, I'm going to go over a few things that you need to know or remember about systems of equations. Number one, if the instructions ask you to use a specific method, then make sure you use that method. If it asks you to use graphing, make sure you use graphing. If it says use substitution, make sure you use substitution. If it says use elimination, make sure you use elimination. If you don't use the specific method they ask you to, then they could probably count it wrong because you're not following directions. So make sure you use the specific method they're asking you to use. Number two, if the instructions say use any method or says just solve, then you can use any method you want to. But it would probably be a good idea if the equations are in standard form that you use elimination because it's already set up for elimination. It might be a good idea if they're both in slope-intercept form to go ahead and use substitution. So if it's in standard form, good idea to use elimination. If it's in slope-intercept form, good idea to use substitution. If one's in one form and one's the other, then you need to make a decision and change one of the equations. When you solve these systems of equations, there are only three possible outcomes. One is the point that they intersect. You graph it, you use elimination or substitution, whatever you do, and you write down the coordinates for that point where they intersect. You could have no solution. That means you graphed them, you found out the lines were parallel, and we're going to go over what to do or how to tell whether or not it's no solution if you have used the method elimination or substitution. Or the answer could be infinite solutions. That means both lines are exactly the same. These are the three possible answers that you can write down on this. You can write down the ordered pair, you can write down the words no solution, or you can write down the words infinite solutions. Those are the three possible outcomes, the three possible answers when doing this systems of equation. If you're solving these using one of these methods, substitution or elimination, and both variables go away, both variables are eliminated, then the answer is either no solution or infinite solutions. And the way you tell is this. With what you have left over, if the numbers are equal, then you write down infinite solutions as the answers. If you're solving this using elimination and both variables go away, and then you've got two numbers sitting there and those two numbers are equal, then you write down the words infinite solutions. That's telling you that those two lines were actually the exact same line. If you go through all the processes of elimination or substitution, whichever one you're using, all the variables go away and you're left with two numbers and those two numbers are not equal, then you're going to write down the words no solution. That means those lines were parallel. They never intersected each other. First off, it's not telling me to use a specific method. It's just saying solve this system of equation. The system of equation is already in slope-intercept form. Since it's in slope-intercept form, it would probably be a good idea for me to go ahead and use substitution. That's what I'm going to do. I'm going to use substitution. It's telling me that y is equal to this and y is equal to this. So that means those two expressions are equal to each other. I'm going to set them equal to each other. 3x minus 1 is equal to 3x plus 1. I'm going to get rid of the variable that's in the wrong spot. That would be this 3x right here. I'm going to subtract 3x from both sides. When I do that, not only is this one over here eliminated, but this variable is also eliminated. And the only thing I have left is negative 1 is equal to 1. Remember, I said if the numbers were not equal, then, and this is a situation where the numbers are not equal, then you're going to write down no, there is no solution to this one right here. These lines are actually parallel. They're asking me to solve this system of equations. So I look at what form these are in, and it's going to tell me or give me an idea of which method I need to use. Since these are almost in standard form, the x's and the y's are all lined up, probably be a good idea for me to use elimination on this. If I use elimination, let's go ahead and try to eliminate these x's right here. To eliminate these x's, I need to change this one right here to something that will cancel out negative 8x. The opposite of negative 8x is positive 8x. So I need to multiply this and everything else in this equation by something to change it into positive 8x. A negative times a negative is a positive. 2 times 4 is 8. So I need to multiply this bottom one by negative 2 to change it to a positive 8 to cancel that one out. So I'm going to do that. I want to multiply this entire equation down here by negative 2. Negative 2 times negative 4x, positive 8x. Negative 2 times negative 8y, positive 16y, is equal to 10 times negative 2, negative 20. I'm going to bring this equation over, and then we're going to combine them together. And let's see what happens. Yes, these x's are eliminated, but not only are the x's eliminated, the y's are eliminated. Negative 16y, positive 16y, they cancel each other out. So I have nothing left over here, and the number we have to represent nothing is 0. 20 minus 20 is 0. So this is one of these situations where I need to make a decision. Is the answer going to be no solution or infinite solutions? If the numbers right here were different, I would write down no solution. But the numbers are the same. The numbers are equal. If the numbers are equal, I'm going to write down infinite solutions. When you write down infinite solutions, basically what you're saying is this line and this line are exactly the same. And they are. These two lines are exactly the same. So once you solve these and both variables go away, you've got a decision to make. And the decision is made based on whether or not the numbers are the same. The numbers are the same, it's infinite solution. If the numbers are different, it's no solution.